Did you know Saturn could float in a river? Yet its rings would stretch wider than 20 Earths placed side by side. Tonight, we will drift between those broad, icy rings, counting quiet moonlets and listening to frozen crystals click together like distant wind chimes. We will learn why some ring particles are smaller than a grain of sand, while others rival city blocks, and how shepherd moons keep edges sharp by stealing loose ice. By the end, you will feel yourself glide in slow orbits, breathing in rhythm with the steady spin of this beautiful gas giant. Good evening, everyone, and welcome to another gently fact-filled expedition through the cosmos. I promise peaceful sleep will arrive before our voyage concludes. Please share in the comments what part of our blue planet you call home, and what time your clock displays right now. It is always delightful to know which latitude and longitude cradle your pillow this evening. Remember to subscribe for daily celestial journeys, but please tap that button only after you sail into deep, restful sleep. Otherwise it will not count in the mission log. Let each muscle relax as though gravity has lowered its volume. Our journey through the universe tonight begins on a viewing deck aboard an orbiting research vessel named Whisper. Whisper hovers just outside Saturn's main ring plane, bathing in pale golden light reflected from cloud tops below. Saturn's atmosphere is mostly hydrogen and helium, giving the planet its soft pastel bands and lightning storms that flash silently in vacuum. Scientists have watched these storms linger for months, longer than any thundercloud on Earth. Below us, the rings appear solid, yet they are incredibly thin, seldom thicker than a city office block. This planet's rings likely formed less than 100 million years ago, making them younger than many dinosaurs once roaming Earth. Their brightness suggests constant recycling, with collisions chipping fresh ice from older fragments. We angled the vessel toward the outer ring, guided by a small shepherd moon named Pan. Pan orbits inside a gap called the Encke Gap, clearing debris with gentle gravity. Its shape resembles a flying saucer because ring particles collected along its equator over time. Ice grains in this region are nearly pure water, sparkling like powdered diamonds. Light from Saturn's distant sun scatters through them, casting faint rainbows on Whisper's hull. We passed near a propeller feature, created when an unseen moonlet disturbs nearby ice. These propellers are signs of hidden bodies, too small to be full moons, yet large enough to carve spiral wakes. Next, we glide above the wider Cassini Division, a dark band between the A and B rings. This gap exists because the moon mass tugs particles away every time they complete 2 orbits for its one. Such gravitational rhythms are called orbital resonances, and they sculpt the ring system like invisible hands. Beneath us, the dense B ring glows brightest, reflecting sunlight in broad ripples. The B ring holds most ring mass, though its precise thickness remains a mystery because radar signals scatter unpredictably. Some models suggest hidden wake structures, long ridges of ice packed like traffic on a quiet highway. We slow the vessel and descend into the ring plane, where particles drift at walking speed relative to us. Impact sounds are muffled through hull plating. Soft taps like distant rain on a greenhouse roof Each fragment follows Kepler's laws, orbiting faster when closer to Saturn and slower when farther, maintaining graceful order. A lone boulder tumbles gently, its surface carved by countless micro-impacts that left tiny glittering craters. These micro-impacts release dusty jets that give the rings a faint, ghostly atmosphere called the charged particles from Saturn's magnetic field collide with this dust, creating ultraviolet glows invisible to human eyes. Whispers sensors translate these glows into gentle tones. We can hear a quiet chime rising and falling. We record the melody, labeling it Ring Song 1. Farther out lies the F-ring, narrow and braided like silver rope. To shepherd moons, Prometheus and Pandora tug at this ring, pulling strands that twist into beautiful knots. Prometheus steals material on each pass, then releases it, creating bright streamers that fade over hours. This dance repeats every 15 hours, a cosmic loom weaving and unweaving ice threads. Some F-ring particles form temporary clumps, dubbed moonlets, which appear and vanish within days. These moonlets collide gently, spraying ice flakes that keep the ring vivid and fresh. We angle upward, leaving the ring plane. Below, Saturn's cloud tops whirl in bands, moved by jet streams reaching 1,000 miles per hour. Near the North Pole sits a geometric wonder, a hexagon-shaped storm larger than Earth, rotating like a vast atmospheric gear. No other planet shows such a stable six-sided vortex. The pattern may form where westward and eastward winds meet, creating standing waves frozen into shape. We pause to admire this silent hexagon bathed in winter twilight. Saturn's year spans almost 30 Earth years, so each polar season lasts more than 7 Earth years. Long seasons allow storms to evolve slowly, giving them time to grow into immense, mesmerizing structures. You breathed deeply, imagining cool hydrogen wind brushing against your visor. Let your heart beat slow to match the planet's calm rotation. Feel the stillness settle, like snow on a quiet evening street. We adjust our course toward Titan, the largest moon of Saturn and the second largest moon in this entire solar system. Titan has a thick, golden-orange atmosphere made mostly of nitrogen, similar to Earth, but with a hazy twist of methane. Krakenmeer is so wide it could hold all of the 5 Great Lakes combined. Its air pressure is slightly higher than Earth's, and radar scans map its dark, glassy surface, which means if you stood there in a protective suit, you would not need a pressurized helmet. It is the only moon known to have lakes and rivers, though. They are filled not with water, but with liquid methane and ethane. Like the faintest exhale across a candle flame, we see how wind direction changes their curves over time. Raindrops fall from thick orange clouds, forming streams that carve winding canyons through icy highlands. One of Titan's largest lakes, stretching for hundreds of miles, Whisper floats slowly above this alien sea. Waves rise less than 1 foot high, barely rippling the stillness due to Titan's low gravity and thick air. Wind there is gentle, feeding Saturn's fainty ring with fresh material. In this world, passing close to Enceladus sprays plumes of icy water from its south pole. Another moon with surprises. Methane behaves like water, flowing in rivers, and the grains feel like plastic powder if touched, evaporating into clouds, and falling again in a cycle all its own. The dunes of Titan ripple across its equator. These dunes are made not of sand, but of dark hydrocarbon grains formed from particles falling from the upper atmosphere. The color is charcoal gray. Flying over these endless ridges, Whisper's instruments detect faint electromagnetic pulses rising from below, possibly from a salty ocean hidden beneath the crust. This ocean could be as deep as 200 miles, locked beneath layers of ice and rock. If life were to exist here, it would have to be very different from life on Earth, thriving in cold, dark, and chemical-rich conditions. We leave Titan slowly. Though much smaller, these plumes come from underground reservoirs. NASA's Cassini spacecraft once flew directly through a plume, finding water vapor, organic molecules, and salt. This discovery made Enceladus a top candidate for hidden life in our solar system. The ice particles fall back onto the moon's surface, making it the most reflective object we know. Sunlight bounces off Enceladus so strongly that it appears almost white in the sky. The ice crust hides a global ocean, warmed by tidal forces from Saturn's pull. As the moon stretches and flexes, internal heat builds, keeping the subsurface liquid from freezing. We drift above the tiger stripe cracks, where the geysers rise, listening to distant hisses of escaping vapor. The sound is soft and steady, like wind through a grove of pine trees. Back toward Saturn we return, where smaller moons orbit within the rings themselves. Atlas, Daphnis, and Pandora all help keep the ring structure neat, though their orbits can wobble slightly over time. Daphnis creates wave patterns on the edges of the Keeler Gap, forming graceful ripples that mimic the wakes of boats on a pond. These ripples measure only a few kilometers high, but their shapes remain visible for days. One moon, Janus, shares its orbit with another moon, Epimetheus, every 4 years. They swap places in a cosmic dance without ever colliding. This phenomena is called co-orbital motion, and it is rare in nature. They act like careful partners on a skating rink, moving in harmony despite their shared path. We sail past Hyperion, an oddly shaped moon that tumbles chaotically instead of spinning steadily. Its surface looks like a sponge, filled with deep craters and low gravity that lets dust escape. Because Hyperion has such an irregular shape, its rotation is unpredictable and never repeats the same way twice. It is one of the few objects in this solar system that exhibits true chaotic motion. Nearby, Iapetus shows a mystery of its own. Its surface is half bright as snow. Scientists believe dust from another moon may have coated one hemisphere, while the other remained icy. A tall ridge runs along Iapetus's equator, making it look like a walnut from some angles. This ridge may be the remains of a longer-lapsed ring, or the result of early rapid spin that pushed material toward the center line. Whisper drifts over this towering wall, silhouetted against a slowly turning planet below. The silence is deep, the kind that hums gently behind your thoughts. Take a moment to breathe slowly, imagining yourself curled up in the corner of the ship's viewing lounge. Let your eyes grow heavy as Saturn's slow rings spin like ancient clocks. Outside the window, the sunlight begins to dim as we enter the planet's shadow. You feel the peace of slow orbits, patient moons, and a gas giant whispering across the void. Our journey through the rings continues as we turn toward Saturn's northern hemisphere. The winds on this planet are powerful, faster than any storm found on Earth. In some regions, they reach speeds of over 1,000 miles per hour. The air is mostly hydrogen and helium, like the sun, but much cooler and denser. There are no solid surfaces here, only thick clouds and deeper layers of gas. As we float downward, the clouds become denser, shifting from soft cream colors to deeper golden browns. Saturn's upper clouds are made of ammonia crystals, which swirl into sweeping patterns shaped by the planet's rotation. Below those, deeper clouds form from hydrogen sulfide and water ice. These clouds mix slowly, forming soft bands that stretch across the entire planet. Some of Saturn's storms are centuries old, locked into powerful jet streams that guide their paths. The most famous of all is the hexagon, at the planet's north pole. This hexagon is a six-sided weather pattern, larger than Earth, and stable for decades. Scientists believe it is caused by jet streams moving at different speeds around the pole. Its edges are sharp, not rounded like a typical hurricane. In the center of the hexagon is a massive polar vortex with an eye nearly 2,000 miles wide. This storm spins like a spiral galaxy, rising many miles above the surrounding cloud layers. During the Saturnian summer, sunlight illuminates the vortex, revealing layers of swirling haze and storm cells. Winds circle around it at over 300 miles per hour. The pattern is so stable that it returns season after season, never drifting from its place. We drift just above the northern cloud tops, watching the golden clouds swirl in endless slow motion. The air outside is thick with ammonia haze, softening the sunlight into pale pastel colors. Faint flashes of lightning flicker far below, where deep thunderstorms rumble inside the gas layers. These lightning bolts are more powerful than anything on Earth, sometimes thousands of times stronger. They light up the planet's clouds with brief, silent sparks. Deep in these clouds, scientists believe water-based storms may exist, much like those on Earth. These storms could create hailstones, made not of ice, but of diamonds. High pressure deep within Saturn may compress carbon into diamond crystals that fall like rain. These diamond rains would eventually melt in the heat below, never reaching the core. Beneath the clouds lies Saturn's metallic hydrogen layer. Under immense pressure, hydrogen becomes so dense that it starts to act like a metal. This strange form of matter can carry electric currents, generating Saturn's magnetic field. Saturn's magnetic field is strong, but not as strong as the one around Jupiter. It creates glowing auroras at both poles, where charged particles from the sun collide with gases in the upper atmosphere. Unlike Earth's auroras, Saturn's glow in ultraviolet light, invisible to the human eye. Our ship's sensors translate them into color, casting a soft lavender shimmer across the poles. These auroras pulse and shimmer, changing shape with each solar gust. Back inside Whisper, soft lights flicker along the observation dome, mimicking the auroras outside. The ship moves gently now, following the curve of the equator. Below us, the ring shadows stretch across the golden clouds like dark threads. We pass over a long, thin band called the equatorial jet stream. This stream flows faster than the others, whipping around the planet's waist just above the rings. Tiny particles spin in sync, barely larger than grains of sand. Some are icy, others rocky, each moving with perfect grace. Saturn's gravity holds them in orbit, shaping their paths through delicate pressure and pull. A small moonlet slips through the rings, leaving a spiral wake behind it. These trails can last for days, slowly twisting with the planet's rotation. Even the tiniest moons leave gentle brushstrokes in this frozen painting of motion. We are nearing the end of this passage through Saturn's rings and clouds, but not the end of its story. You are safe and weightless now, adrift in the beauty of this giant's gentle embrace. Our course now turns outward, toward the edge of Saturn's glorious ring system. The rings may seem solid from a distance, like a giant disk around the planet, but they are made of countless individual particles, each orbiting at its own graceful speed. Some particles are the size of sugar crystals, others are as large as school buses, tumbling end over end through the vacuum. The rings stretch out more than 280,000 kilometers from Saturn's surface. That is nearly 3/4 of the distance from Earth to the Moon. Yet the rings are incredibly thin, only about 10 meters tall in most places. That is thinner than a single story of a house compared to the entire width of North America. Imagine a sheet of tissue paper stretched over a football field. That is the kind of scale we are talking about. The rings are divided into 7 main sections, labeled alphabetically in the order they were discovered. The brightest and most massive is the B ring. It is dense, wide, and nearly opaque in places. The A ring lies just beyond it, separated by a thin gap called the Cassini Division. This division is caused by the gravity of Saturn's moon Mimas. Mimas creates a resonance with ring particles that clears out this quiet path. Mimas is sometimes called the Death Star moon because of its giant crater. The crater is named Herschel and spans nearly 1/3 the moon's entire width. Farther out, the F ring dances with complexity. It is braided, twisted, and ever-changing. Tiny moonlets, called shepherd moons, orbit near the F ring. They pull on the ring's edges with every pass, tugging them into narrow streamers. They stretch and pull the ring into waves and knots. These shepherd moons are named Pandora and Prometheus. As they pass, no 2 orbits look the same. Even small differences in mass or path create stunning effects. Ring particles can clump together into temporary but Saturn's gravity pulls them apart again before they grow too large. This process repeats over and over, like cosmic breathing. The ring system is not permanent. It is slowly fading over time, shedding particles into space. Some fall towards Saturn as dusty rain. This dusty rain is made of charged ice grains that spiral along magnetic field lines. Scientists believe the rings may only last another 100 million years. That might sound long to us, but it is just a moment in the life of a planet. Saturn may have formed without rings, gained them later, and could lose them again. Some believe a moon was torn apart by Saturn's gravity to create the rings. Others think the material is left over from the early solar system. No one knows for certain, but watching them shimmer and swirl, one might think they have always been there. The outermost E-ring is faint and wide. It is made mostly of tiny ice particles from the moon. Enceladus is covered in bright ice and has geysers that shoot water into space. These geysers erupt from fractures near the South Pole. The ice and vapor feed the E-ring, making it the only ring in our solar system created by an active moon. Our ship slows as we reach the edge of this delicate loop. We are ready now to visit the moons of Saturn, each one holding mysteries of its own. Our first destination is the icy world of Insomnia. It is one of the brightest objects in this solar system, because its surface reflects nearly all sunlight. This reflectivity is due to a thick coating of freshwater ice. Enceladus is small, only about 500 kilometers across. That is about the width of the state of Arizona, but it holds a secret ocean beneath its frozen shell. Warm water escapes from cracks in the South Pole region. These cracks are nicknamed tiger stripes due to their blue coloration and long gashing form. The geysers blast a mixture of water vapor, ice particles, and organic molecules into space. Some of the particles become part of Saturn's E-ring, others fall back to the moon's surface, creating a snowy landscape. The geysers are powered by tidal heating. As Enceladus orbits, Saturn gravity flexes its interior. This movement produces enough warmth to keep its hidden ocean in a liquid state. The presence of liquid water, heat, and organic chemicals makes Enceladus a top candidate for potential life. Some scientists think microbial life could exist in its underwater seas. Next, we glide past Titan, Saturn's largest moon. Titan is bigger than the planet Mercury. It is the only moon in this solar system with a thick atmosphere. This atmosphere is made mostly of nitrogen, like Earth's, but it also contains methane, which forms clouds and rain. Rivers and lakes on Titan are filled with liquid methane and ethane. Instead of water, the largest lake is called Krakenmeer. It is larger than the Great Lakes combined. The shorelines of these alien seas are sculpted by waves and rainfall. Titan's surface is cold enough to freeze water solid like rock. Beneath its crust lies another possible ocean of liquid water. Some think this ocean may also contain ammonia, which lowers the freezing point. If life exists on Titan, it might be very different from anything on Earth. We drift now toward Iapetus, a moon with a stark contrast. One half is dark as coal, while the other is bright as snow. This dramatic coloring puzzled astronomers for centuries. The dark side is covered in a thin layer of dust from outer moons. This dust absorbs sunlight, warming the surface. The warm ice sublimates and travels to the cold side, making it even brighter. This thermal feedback enhances the contrast over time. Iapetus also has an equatorial ridge, a giant mountain range circling its waist. This ridge is so tall that it makes Iapetus resemble a walnut. Its origin remains a mystery. It could be the remains of a collapsed ring or a frozen equator bulge. Now we visit Hyperion, a lumpy moon that spins it tumbles chaotically through space. Its surface is spongy, filled with deep craters. Hyperion is extremely porous, like a cosmic pumice stone. It has a density so low that it would float in water. Some of its craters are dark inside, likely filled with frozen hydrocarbons. Its low gravity means impacts leave unusually shaped holes instead of flattening them. We now prepare to head back toward the rings, brushing past the shepherd moons once more. As we return to the rings, we pass by Pandora. Pandora is one of the small moons that helps shape the outer edge of Saturn's narrow F-ring. Along with its companion Prometheus, it creates gravitational tugging that keeps the ring in check. These moons are called shepherd moons. Prometheus, the inner shepherd, steals particles from the F-ring. Pandora, the outer shepherd, chases them away again. Their gravitational dance stirs ripples and streamers in the ring's structure. This dynamic interaction makes the F-ring one of the most chaotic and ever. The F-ring sometimes shows sudden bright clumps and strands that twist and tangle. Scientists believe these may result from collisions with small, hidden moons. The F-ring is narrow, only a few hundred kilometers wide, but incredibly long. If unwrapped, it would stretch nearly 600,000 kilometers in length. That is 1.5 times the distance from Earth to the Moon. We drift slowly now toward the inner B-ring. The B-ring is the brightest and most massive of all Saturn's rings. It spans over 25,000 kilometers in width. Its particles range from tiny grains to house-sized chunks. Despite its massive appearance, the B-ring is still incredibly thin. It is only about 10 meters thick. The brightness of this ring comes from its high reflectivity. This ring reflects more sunlight than freshly fallen snow. We now float through a quiet space between the B and A rings. This region is known as the Cassini Division. It was first observed by astronomer Giovanni Cassini in 1675. He saw the division through a primitive telescope and could only imagine its cause. Today we know it is caused by a gravitational resonance with one of Saturn's moons. That moon is Mimas, the Death Star-like moon with a massive crater. Every time a ring particle orbits Saturn twice, Mimas completes one orbit. This repeated tug creates a gap, pushing particles away over time. Mimas itself has a large crater called Herschel. Herschel spans 1/3 the diameter of the entire moon. If Earth had a crater that size, it would stretch from New York to California. We pass now beneath the shimmering ring. It lies farther from the planet than the B-ring. The A-ring contains a curious feature known as the Encke Gap. Within this gap orbits a small moon named Pan. Pan looks like a flying saucer. It has a pronounced equatorial ridge created by gathering ring particles over time. Pan's gravity clears a path through the ring, sculpting the gap. Its orbit causes waves and wakes to ripple through nearby ring material. Another small moon inside a ring gap. We drift past Pan and turn toward Daphnis. Daphnis orbits within the narrower Keeler gap. Its motion creates vertical waves along the ring's edges. These waves can rise up to 1.5 kilometers tall. They resemble ripples on a pond, but in the icy vacuum of space. As we drift beyond Daphnis, we begin to notice another mysterious feature within the A-ring. These are the propeller-shaped disturbances scattered through the ring. They are caused by moonlets, too small, too clear, full gaps. Instead, their gravity disturbs the surrounding ring material, forming patterns that resemble airplane propellers. Each of these propeller features can stretch for several kilometers. The moonlets themselves are often just a few hundred meters wide. They are like hidden pebbles creating ripples in a frozen pond. Some of these propellers have even been tracked over time, slowly migrating within the ring. They have names inspired by famous aviators and explorers. One of the most prominent is nicknamed Blériot, named after the first man to fly across the English Channel. From here, we begin our descent toward the D-ring. The D-ring is the innermost and faintest of Saturn's main rings. It lies closest to the planet and is barely visible. Its particles are very small and sparse. Over time, it appears to be slowly spiraling inward. Some of its material may even fall into Saturn's atmosphere. This ring is constantly reshaped by Saturn's magnetic field. In 2011, a sudden bright spiral formed in the D-ring. Scientists believe it was created by a meteor impact. This spiral pattern gradually wound tighter over time. We now approach the C-ring, nestled between the D and B rings. It is sometimes called the crepe ring due to its dim, gauzy appearance. The C-ring contains many mysterious ringlets and waves. These patterns are shaped by oscillations inside Saturn itself. These are known as density waves. They are like seismic tremors traveling through the rings. By studying them, scientists can infer details about Saturn's interior structure. It is a form of cosmic seismology. The C-ring also has zones where particles are mysteriously missing. These are known as plateaus, where density drops for unknown reasons. Some scientists believe electrostatic charging plays a role. The particles in the C-ring may cling together like tiny magnets. We now float above the equator of Saturn, gazing down upon the full expanse of its rings. From this height, they resemble the grooves of an ancient vinyl record, each ring etched with the story of collisions and creation. Saturn's ring system spans over 280,000 kilometers from end to end. That is nearly 3/4 of the distance from Earth to the Moon. Yet the entire system is only about 10 meters thick. If you stood in the rings, you would hardly see them at all. Despite their size, the total mass of the rings is relatively small. All of Saturn's rings together weigh less than one of its moons. Their mass is roughly equivalent to that of the Moon mass. This has led to debates about how long the rings might last. Some scientists believe they are slowly eroding. Particles fall into Saturn or drift away. In time, Saturn may become a ringless planet. But for now, they remain a breathtaking spectacle. Beyond the main rings lies a vast region known as the E-ring. This ring is incredibly wide, stretching from the orbit of Mimas to that of Titan. It is also the most diffuse of Saturn's major rings. The particles here are tiny, mostly despite its faintness. It is primarily fed by one of Saturn's most intriguing moons. Enceladus is a small, icy world with a hidden ocean beneath its crust. From its southern pole, Enceladus ejects plumes of water, vapor, and ice. These geysers erupt from long fractures called tiger stripes. As the plumes escape into space, they feed the E-ring. This makes the E-ring unique among Saturn's rings. It is the only one actively replenished by a moon. The particles from Enceladus are fresh and clean. This gives the E-ring a brilliant blue color when viewed in certain light. It is one of the few rings in the solar system with such a hue. The plumes of Enceladus were first observed by the spacecraft Cassini. Cassini flew through the jets multiple times, sampling their contents. It found salty water, simple organic molecules, and even traces of hydrogen. These ingredients suggest Enceladus could harbor life. If so, the E-ring might be made partly from the breath of alien oceans. You might feel like you are swimming through a veil of snow, floating slowly through this ring. But unlike snow, the grains are shaped by the forces of electromagnetism. Solar radiation and Saturn's magnetic field bend the paths of these grains. This makes the E-ring appear differently depending on where you are. In sunlight, it shimmers faintly. It nearly vanishes. In shadow, it is a ring of whispers and absence. Farther out still, we reach the G-ring. This ring is even more mysterious than the E-ring. It lies between the orbits of Mimas and for many years, scientists could not determine what kept it alive. Eventually, they discovered a tiny moonlet named Aegion. Aegion orbits within the G-ring and acts as a source of fresh particles. Collisions with micrometeoroids kick up dust from its surface. This dust feeds the ring, much like Enceladus feeds the E-ring. Aegion is only a few kilometers wide, almost invisible on its own. Yet it sustains an entire segment of Saturn's architecture. The G-ring is shaped into an arc by Saturn's magnetic and gravitational forces. This gives it an asymmetric appearance, like a drawn-out sigh of ice. Even farther still lies the vast Phoebe ring. The Phoebe ring is unlike any other ring in the solar system. It is the largest and most distant of Saturn's rings. It begins about 6 million miles from the planet. It stretches for more than 10 million miles beyond that. If visible to the naked eye, it would span the width of 2 full moons in the sky. Yet it remained undiscovered until 2009. The reason is that it is made of dark, nearly invisible material. Most of its particles are made from carbon-rich dust. This dust barely reflects sunlight. The Phoebe ring is tilted relative to Saturn's main rings. It orbits in the opposite direction of most of Saturn's moons. This makes it a retrograde ring, an unusual feature in planetary systems. It is named after the moon Phoebe, which orbits within the ring. Phoebe is an irregular, captured moon thought to come from the Kuiper Belt. The Kuiper Belt is the same region where Pluto resides. This gives Phoebe and its ring a mysterious, ancient quality. The particles in the Phoebe ring were likely knocked loose by micrometeoroid impacts. These particles drift inward slowly over millions of years. Eventually, they interact with other moons, including Iapetus. Iapetus is another of Saturn's most fascinating moons. It has one side that is bright as snow. Its other side is dark as soot. The cause of this contrast is partly due to the Phoebe ring. Dust from the ring collects on one side of As the moon orbits Saturn, it sweeps up dark material. This darkening warms the surface, melting nearby ice. The melted ice then migrates away, leaving even more dark material behind. This process is called thermal segregation. It is a slow transformation sculpted by shadow and sunlight. So even though the Phoebe ring is faint, it leaves a lasting fingerprint. It alters the surface of entire moons. It shapes worlds in silence. Its particles are ancient, some possibly older than Saturn itself. To float through this ring is to move through time. There are no dense bands of ice here, only faint wisps of dust drifting like ashes in twilight. The silence would be absolute. The stars would look sharper out here. Without the reflection from icy rings, space would seem darker. This is where Saturn's gravity begins to loosen its hold. Beyond the Phoebe ring, interplanetary space stretches outward. Tiny particles from the ring drift farther still. Eventually, they are captured by the solar wind. Some are carried toward the sun. Others escape the solar system entirely. They become dust in the galaxy, tiny remnants of Saturn's most distant halo. And so, the story of Saturn's rings ends not with a wall of ice, but with a whisper of dark dust fading into the stars. We now turn our attention to Saturn's mighty This is a vast bubble carved into the solar wind by the planet's magnetic field. It is second in size only to Jupiter's magnetosphere. Charged particles stream outward from the Sun. Saturn's field catches and bends them like a gentle net. Some of these particles spiral down magnetic lines into the upper atmosphere. They collide with hydrogen, releasing ultraviolet light. Although invisible to human eyes, instruments paint these lights in lavender. The auroras form rings around both poles. They pulse in rhythm with solar storms, millions of kilometers away. During strong outbursts, the auroras brighten and climb higher. Their shapes ripple and twist like silent curtains. This is Saturn's way of singing with the sun. Spacecraft have recorded faint radio waves linked to these lights. The sounds resemble distant whistles and chirps. Listening to them feels like tuning a fragile music box. These radio emissions vary with the planet's rotation. They allow scientists to measure Saturn's true day length. Saturn's cloud bands hide the rotation of deeper layers. The magnetic pulse provides a more reliable clock. It ticks every 10 hours and 33 minutes. A day on Saturn ends almost before lunch on Earth. Yet the planet's atmosphere flows more slowly in places. Cloud belts near the equator move at slightly different speeds. This creates shear zones where storms grow. Cassini observed one great storm encircling the planet in 2010. It began as a small white dot. Within weeks, it wrapped around the globe. Lightning inside that storm flashed 10 times more brightly than any on Earth. Each bolt illuminated clouds hundreds of kilometers wide. Storm clouds rose high enough to poke into the stratosphere. This stirred chemicals such as ammonia and they created hazes that lingered for many years. Some of those hazes drifted toward the rings. They stuck to icy particles. Over time, ring particles darken as they sweep up this falling rain. Scientists call this process ring rain. It is one reason the rings will slowly lose brightness. Ring rain also carries water vapor into Saturn's upper atmosphere. This vapor can alter cloud chemistry. Everything in the Saturn system, from rings to moons, is linked. Pull one thread and another trembles. We steer whisper toward a narrow window between ring particles. The ship's shields deflect small grains, like raindrops on glass. Each tap sounds like a gentle drum roll in the hull. Outside, sunlight dims as we dip within the shadowed side of the rings. Icy particles glow faintly, lit by the planet's reflected light. It feels as though we are sailing through frozen stardust. We pause engines and drift, letting Saturn's gravity carry us forward. You breathe deeply, matching your heartbeat to the quiet orbit around you. As we drift silently beneath the rings, particles cast shadows on one another. These miniature eclipses create speckled light patterns across our ship's hull. Each particle, no larger than a snowball, tumbles slowly in Saturn's grip. Some rotate like lazy tops, while others remain still, frozen in eternal pause. These icy grains reflect about 60% of the sunlight that strikes them. That makes Saturn's rings among the most reflective surfaces in the solar system. Some of the brightest areas shine like freshly fallen snow. Their gleam is so intense they can be seen with small backyard telescopes. The quiet beauty surrounding us is deceptive. The rings may appear solid from a distance, but they are mostly empty space. If you compressed all the material in the main rings, it would form a moon no larger than 100 kilometers wide. Their thinness is also surprising. Most of the rings are only about 10 meters thick. That is less than the height of a diving platform at an Olympic pool. Despite their vast spread spanning over 280,000 kilometers, they are razor-thin compared to their width. The rings are labeled from inner to outer as D, C, B, A, F, G, and E. These names were assigned in order of discovery, not their physical placement. The B ring is the thickest and brightest of them all. It blocks much of the light from Saturn during occultations. Between the A and B rings lies the Cassini Division. This dark gap is not truly empty, but contains fewer, darker particles. It is kept clear by the gravitational influence of the moon. My mass, sometimes called the Death Star moon, has a giant crater called Herschel. This crater is over 100 kilometers wide, almost a third the moon's diameter. If my mass were any larger, gravity would have pulled it into a more spherical shape. Its orbit resonates with the particles in the Cassini Division. As my mass moves, it nudges these particles into new paths, clearing space like a cosmic broom. Farther out lies the F ring, a narrow, twisted ribbon guarded by shepherd moons. These moons, Prometheus and Pandora, tug the ring into braids and knots. Sometimes particles break away, only to be herded back by gravitational nudges. The F ring is dynamic. Its shape changes with every orbit. It may appear fragile, but it has persisted for millions of years. The E ring is even more delicate. This ring is composed mostly of microscopic ice grains. It is replenished continuously by the moon. Enceladus spews water vapor from icy geysers near its south pole. These plumes reach hundreds of kilometers into space. As the vapor freezes, it adds to the E-ring's shimmering veil. This ring stretches farther than any other, spanning nearly 1 million kilometers. It is so faint that it can only be seen when lit from behind. Despite its size, the total mass of the E-ring is barely measurable. Its presence, however, reveals the hidden breadth of Enceladus orbits within the densest part of the E-ring. Its surface is coated in bright ice, making it one of the most reflective objects in the solar system. Over 90% of sunlight that hits Enceladus bounces off. Its high reflectivity is partly due to its constantly renewed surface. Each geyser eruption repaints the moon in frosty white. These eruptions are powered by tidal flexing Saturns. Gravity kneads the moon like dough. This kneading generates internal heat, keeping pockets of liquid water beneath the crust. That subsurface ocean could be more hospitable to life than anywhere else beyond Earth. Scientists believe that heat, water, and organic molecules have all been detected there. If life does exist, it might dwell near thermal vents, just as it does on the floor of Earth's oceans. Back near the rings, the tiny shepherd moons keep order. Prometheus dips into the F-ring, stealing material and creating streamers of particles. Pandora's gravity pulls gently at the outer edge, keeping the ring confined. The resulting gravitational tug-of-war forms bends, gaps, and spirals. These patterns evolve hour by hour. If you could watch the F-ring for a full day, it would appear to breathe. Just beyond, the G-ring is a ghostly band of dust particles. It was long overlooked due to its dim nature. Scientists discovered it using light scattering during spacecraft. The G-ring is fed by a small, mysterious moon named Egion. This moon is only about half a kilometer wide. Its collisions with nearby debris help sustain the faint ring. Farther still, the D-ring brushes close to Saturn's atmosphere. It is the thinnest and faintest of the main rings. Its particles spiral inward, eventually falling into the planet's upper clouds. When that happens, auroras may shimmer near Saturn's poles. These auroras are created by interactions between ring matter and Saturn's magnetic field. Saturn's magnetic field is symmetrical and like Earth's and remains a puzzle for planetary scientists. Its field may be shaped by deep liquid layers beneath the cloud tops. These layers, rich in metallic hydrogen, generate electrical currents. Such currents give rise to the magnetic field, which rotates almost in perfect alignment with Saturn's spin. This symmetry may be why the length of Saturn's day is so hard to measure. It was once estimated using radio waves, but those signals fluctuate. Now, scientists track surface storms to refine the timing. Saturn's day lasts roughly 10.5 Earth hours. Its seasons, however, span over 7 Earth years. This is due to its wide, 27-degree axial tilt. As Saturn orbits the Sun, its rings shift like a giant celestial clock. Sometimes we see them sometimes they bloom fully open, like petals on a cosmic flower. During equinox, sunlight strikes the rings, edge on, casting long shadows onto the planet. These moments are rare and reveal details usually hidden in glare. Saturn's rings may seem eternal, but they are slowly disappearing. Gravity drags their particles into the planet at a rate of 10,000 kilograms per second. Over time, this process will erase them. In 100 million years, Saturn may become a planet without a halo. But for now, the rings are here, and they are singing. Yes, Saturn's rings generate a soft radio hum as particles collide and bounce. The Cassini spacecraft recorded these ethereal sounds during its orbit. Scientists converted them into audio, revealing chirps and whooshes like an alien lullaby. These songs are not audible in space, but with instruments, they become a kind of music. Some say it is the solar system's most delicate symphony. You can imagine drifting in your ship beside them, eyes closed, listening. Every ring seems to whisper its own quiet tone. The A ring chimes, broad and full. The B ring crackles with hidden voices. The F ring sings softly, like wind against silk. Saturn is not just a planet, it is a performer in a celestial ballet. Each moon, each ring, each shifting shadow, lakes, and even rainbow, made of methane, not water, moves with intention. Back on Titan, storms of methane swirl above smooth plains. Titan has rivers. These hydrocarbon lakes are so cold, they do not evaporate like water does on Earth. When Titan rains, you would see the orange sky and its pale reflection below. It rains slow. Drop by drop, the methane collects and carves canyons. Some lakes are larger than the Great Lakes of North America. Kraken Mare is over 1,000 kilometers wide. The largest, if you could float across it, you might feel small, but not alone. The surface of Titan may one day support robotic sailboats. NASA has plans to explore its lakes in coming decades. Beneath Titan's crust, a salty ocean could cradle something living. Because his telescope was too primitive to resolve the rings, it would not breathe oxygen, but it might still thrive in alien ways. Back on Earth, we look up at Saturn with backyard telescopes. Even small scopes can show its yellow globe and the edge of its rings. Some observers say Saturn is the most beautiful object in the night sky. Galileo was the first to see it, but he did not know what he was looking at. He thought Saturn had ears. Later, astronomers revealed their true form. Christian Huygens correctly identified them in 1655. Over centuries, new details emerged: the gaps, the moons, the shadows. Now, even amateur astronomers can track Saturn's changing view. From Earth, the rings seem to tip up and down across the years. It is because of Saturn's tilt and our own moving orbit. Sometimes we see the rings wide open, like outstretched arms. Sometimes they disappear entirely, turning edge on and vanishing in a single night. These changes are reminders that space is not frozen. It moves slowly, but never stops. Saturn may seem timeless, but it is just one chapter in the solar system's unfolding story. Its rings are not permanent, but they are beautiful while they last. You were lucky to visit them tonight. You counted shadows in the B ring and listened to Enceladus breathe. You drifted between icy particles and traced the tides of Titan. You watched lightning storms light up Saturn's golden clouds. And now, with the journey nearly complete, it is time to close your eyes and rest. Let us float a moment longer, here, just beyond the rings. The ship is quiet now. There is nothing left to chart. No more facts to memorize. No more moons to visit tonight. Only silence, and a slow, distant turning of shadows. The stars are blinking softly above your vessel. Saturn's rings glide past your window like whispered memories. They are drifting ice. Yes, but tonight they are something more. They are a lullaby you can feel in your chest, like a rhythm older than the world, older than any name. Perhaps the universe does not speak in words. Perhaps it speaks in orbit and echo. And tonight it has told you everything it needed to. It showed you how rings are made of broken moons and quiet collisions. It showed you that even gas giants can spin with grace. It reminded you that even frozen storms, millions of miles away, still dance with light. You followed a beam of sunlight across thousands of kilometers of frozen dust. You counted craters on my mass like they were freckles on a sleeping child. You listened to the vapor plumes on Enceladus breathe like waves. You drifted beneath Titan's orange skies and imagined alien clouds. You saw Saturn tip and twirl, wearing its rings like a shimmering scarf. And all the while you listened. You listened to gravity hum. You listened to light bend. You listened to silence. Fill the space between stars. You learned that even silence has texture. That space, even at its emptiest, is never truly empty. There is always motion, always warmth, always light, even if faint. And even now, as Saturn spins behind you and the stars stretch ahead, you are not leaving this moment behind. You are simply closing your eyes and carrying it inward, like a comet cradling starlight. Let your breath become slow and even. Let your body feel as though it too is drifting through the rings. Let your thoughts rise like methane bubbles on Titan's lake, weightless, silent, timeless. You are safe here. You are home, even so far from Earth. The ship will keep floating, the stars will keep turning, and the rings of Saturn will keep singing quietly in your dreams. Thank you for traveling with Insomnia in space. If your eyes are still open, you can gently close them now. But if you are still awake, let me ask, would you like to continue this series from another moon, another world, or let Saturn rest in memory for now? Let me know and comment down below. Campfire sounds and shooting stars will remain to guide you the rest of the way down. We stand near the rim of Valles Marineris, a canyon system so long it could stretch from New York to Los Angeles. Its walls drop 7 kilometers in places. Imagine the Grand Canyon stacked 4 times on itself. Wind whistles through fractured rock, carving new furrows each dusty season. Our lantern glows a warm amber. The ground beneath holds frozen water mixed with rusty soil. Scientists have mapped glaciers hidden under thin layers of dust near these very cliffs. One day settlers may dig shallow wells here and draw meltwater for crops. We walk east toward a gentle slope. The horizon seems closer because the planet curves more sharply than Earth's. A single step lifts red dust that hangs in still air before falling back in slow motion. Gravity allows your boots to bounce. Ahead waits a quiet rover. Its nameplate reads Curiosity. The rover rests. Solar panels folded like sleeping wings. A tiny wind sensor still twitches, recording airspeeds lower than a gentle earthly breeze. Curiosity once found evidence of ancient rivers by detecting rounded pebbles. Rounded edges mean water rolled them for ages. Picture a shallow stream flowing under a pale pink sky 2 billion years ago. The sound would have been a faint burble, lost now to silence. We kneel beside the rover. Its aluminum shell feels cold. A faint hum of stored charge thrums under a panel. Curiosity may travel again when dawn returns in 4 Earth hours. We rise and peer west. A soft ridge marks the flank of Olympus Mons, the tallest volcano in the solar system. Its base would cover the state of Arizona. Its summit stands nearly 22 kilometers above the average surface. Dust storms sometimes roll off this mountain. One global storm in 2018 covered the entire planet for months and dimmed sunlight by 99%. Opportunity rover lost power under that storm and never woke again. A silent tribute stands where it rested. Panels coated in fine red powder. We unfold light camp stools. A thermos pours warm cocoa-scented steam into low gravity. Bubbles rise more slowly here, dancing lazily before popping. You sip and feel warmth spread through chest and arms. The temperature has fallen to minus 70 degrees Celsius, yet inside your suit and this imagined habitat, the air stays cozy and mild. Small heaters hum at your feet, soft blankets drape over knees. High overhead, the Milky Way band glows fierce. Without thick atmosphere, stars do not twinkle. They shine steady, like pinholes punched in an ink sheet. Constellations appear unchanged. Yet Mars sits 50 million kilometers farther from those same stars than Earth. On average, a dust devil spins across the plain. It towers 1 kilometer tall, yet carries little force. Scientists study these vortices because they sometimes brush rovers clean, extending mission life. The swirl passes without sound, a ghostly dancer under starlight. We check the horizon. A faint pale glow hints at sunrise. Within minutes, the first photons will stain the dust, a muted blue. Morning frost may sparkle on shaded rock. We settle back, watching for that blue dawn. It appears first as a thin ribbon above the canyon edge. Dust scatters red wavelengths and lets blue escape unhindered. The effect lasts only moments. Phobos now drops toward the west. Its orbit decays a few centimeters each year. In 40 million years, tidal forces will tear it apart. Debris will form a ring around Mars for another century. The wind sensor clicks softly. A gentle breeze from the north carries the scent of iron. Iron oxide dust gives Mars its color. In a single Earth year, dust falls across the entire planet in layers only, microns thick. You close your eyes for a moment. Heartbeat slows, lungs fill with calm air. The camp heater hum merges with distant rover circuits. Our story pauses here, under a blue sunrise and whispering wind. The rover stirs, ready for another slow trek. We roll our blankets, yet leave them warm for the next dreamer. Mars remains, quiet and vast, waiting for new footsteps. We now wander farther north, toward the region known as Arabia Terra. This plateau holds some of the oldest terrain on the planet, scarred with ancient river valleys. Evidence suggests that billions of years ago, rain may have fallen here. Raindrops likely sizzled as they struck the warm dust, leaving tiny craters in soft ground. We pause beside an old crater rim. Its inner slopes glimmer with hydrated minerals. These minerals form only in the presence of water. They whisper stories of lakes that may have once filled this hollow. Long ago, Mars may have supported a magnetic field. That field disappeared over 3 billion years ago. Without it, solar winds stripped the atmosphere slowly over time. What remains is too thin to support liquid water on the surface for long. Still, frost appears near the poles every winter. Carbon dioxide from the air freezes into dry ice. In the spring, sunlight sublimates the ice back into gas. The result is geysers of CO shooting through cracks in surface frost. We travel by rover now. Its tires crunch softly over each rotation stirs fine dust that never fully settles. There is no wind to clear our tracks right away. We approach a small rise. Below us sprawls the Jezero Crater. This is where NASA's Perseverance rover landed in 2021. The crater once held a river delta full of sediment and clay. Perseverance still explores this region. It searches for signs of ancient microbial life. Scientists chose this site because clays can preserve organic compounds for billions of years. The instruments aboard the rover include a weather station and a drone named Ingenuity. Ingenuity was the first aircraft to fly on another planet. Its blades spin 5 times faster than Earth helicopters to compensate for thin air. Each flight lasted less than 2 minutes, but marked a giant leap for the drone captured panoramic images from above, helping plan future routes. You rest now under a shielding dome. The sky is dark again. Martian days called Salzar. Only 40 minutes longer than Earth days. Your body barely notices the difference, though dreams may drift slower. A projection screen inside the dome displays Earth. It appears as a pale blue dot in the black sky. Carl Sagan once said all of human history happened on that dot. From Mars, Earth feels close enough to whisper to, yet far enough to admire. Nearby, a new plant grows under filtered light. Mars regolith has been tested for growing crops. Scientists have used Earth simulations of Martian soil to grow lettuce and radishes. Future missions hope to cultivate food with recycled water and added nutrients. The base's kitchen smells faintly of tomato soup. Your mug steams gently beside your cot. Outside, temperatures hover near -60 degrees Celsius, but inside, thermal blankets keep your toes warm. The stars blink slowly overhead. From Mars, constellations appear nearly identical to Earth, but their orientation shifts slightly due to Mars's position in orbit. Astronomers can still trace Orion and the Southern Cross. We now leave the base and venture toward the polar region. Here, towering layers of ice build over time. At the North Pole, a permanent ice cap stretches over 1,000 kilometers wide. It contains mostly water ice, with a top layer of frozen carbon dioxide. Some researchers believe these polar caps preserve climate records. Each layer reveals data about ancient Martian seasons. Mars has seasons similar to Earth, though they last twice as long. Its axial tilt and orbit contribute to shifting weather patterns across millennia. The rover climbs a gentle slope. Crystals glint in the soft light. Silica-rich deposits nearby suggest hydrothermal activity once occurred underground. These regions may have offered safe havens for early microbial life. We stop beside a boulder. Etched into its side are thin veins of calcium sulfate. These veins form when water moves through rock. It is a fossilized memory of a time when Mars was wet. The horizon softens as the twin moons rise again. Phobos appears first, tracing a fast path. Overhead, Deimos follows, slower and steadier, like a patient observer. No crickets chirp, no wind sighs, only silence. You recline and stare at the sky. A faint halo surrounds the moons. Ice crystals high in the atmosphere create this illusion. The effect is rare and short-lived, but hauntingly beautiful. The campfire flickers gently beside you now. Its flame dances in low gravity. Each spark leaps high, then drifts like a feather. Your breathing slows. You pull the thermal blanket tighter around your shoulders. The sound of your breathing echoes gently in your helmet. Though there is no wind on Mars tonight, you feel the hush of the landscape. The quiet is thick and slow, like molasses in cold air. As you gaze at the horizon, something remarkable comes into view. A dust devil curls far in the distance, rising like a cinnamon twist in the low gravity. These are not dangerous storms, but tiny whirlwinds that travel across flat plains. Unlike Earth's tornadoes, Martian dust devils can reach up to 8 kilometers in height. They occur because of rapid surface heating during the day. Warm air rises, twisting into columns and picking up reddish dust. They sometimes leave behind tracks that are visible from space. Many orbiters have captured these ghostly fingerprints on Mars's surface. Back at the base, researchers monitor the daily weather report. The average temperature is minus 63 degrees Celsius. The thin air means very little insulation from solar radiation, but specialized suits and shielding keep astronauts warm and safe. You are now reclining in the observatory dome. The transparent roof opens like a flower blooming at dusk. Above, the Milky Way spills across the sky in soft glowing threads. Mars has clearer skies than Earth, especially at night. Its lack of moisture means almost no cloud interference. You see galaxies, star clusters, and meteor trails with surprising clarity. The dome's telescope is aligned with the Syrtis Major region. This dark patch was one of the first Martian features ever observed from Earth. In 1659, Christian Huygens made a sketch of it. That drawing helped measure the Martian day for the first time. It is nearly the same as an Earth day, just 37 minutes longer. You now feel the weight of that time in your eyelids. In the next room, a botanical garden hums softly. Hydroponic trays glow with blue and purple grow lights. There are beans, kale, and even dwarf tomatoes. The roots nestle into nutrient-rich gel and recycled Martian water. Martian greenhouses may someday feed an entire colony. And perhaps more importantly, they may also create breathable air. Photosynthesis converts carbon dioxide into oxygen, exactly what future Mars settlers will need. Already, Earth scientists have grown plants in simulated Martian soil. You wander through the garden and stop by a window. Outside, the ancient Martian surface glows red under starlight. Rocky ridges stretch like frozen waves across the landscape. Each ridge is a chapter from Mars's story, preserved in stone. We drift now toward Elysium. This is one of the flattest places in the solar system. It is also home to NASA's InSight lander. InSight studies the planet's deep interior using a Martian quakes called. Mars quakes reveal how active Mars still is. The crust here shifts just enough to whisper old secrets. These vibrations travel through rock, revealing layers far below the surface. Some quakes lasts only seconds, while others echo for hours. The lander also tracked temperature beneath the soil, and it confirmed that Mars still has a warm heart. Though it lacks tectonic plates like Earth, it is far from frozen. The core may still contain molten rock. Your eyes are now drawn to a crater edge. We pass by a small depression named Santa Maria. Its floor is layered with fine sand and ancient sediment. These layers preserve the history of wind and water on Mars. Nearby, we find a rock shaped like a dragon's tooth. It is made of basalt-cooled lava from ancient eruptions. Volcanoes once shaped the entire Martian crust. In fact, Olympus Mons, the tallest volcano in the solar system, sits far to the west. Olympus Mons is over 21 kilometers tall. That is nearly 3 times the height of Mount Everest. Because Mars has lower gravity, lava flowed more easily and traveled farther. This allowed the volcano to grow wider and taller than anything on Earth. You close your eyes now. The rhythm of space settles into your breathing. The rover hums softly in the distance, and the stars blink like distant campfires millions of years away. We now glide toward the thin haze of the northern lights of Mars. Charged particles from the sun strike the upper atmosphere. They create faint green glows above the horizon. These auroras are weaker than Earth's, but still enchanting. The magnetic pockets that remain guide the lightened, delicate curtains. You watch them wave like silk banners in slow motion. Beneath the glow lies the polar dune field. The dunes look like scalloped chocolate frosting, dusted with powdered sugar. Carbon dioxide ice clings to the ridges during winter. In spring, it sublimates and leaves spider-shaped patterns. Scientists call these formations gas escapes from vents and carves dark fans on the surface. The patterns resemble branches of silent trees. They fade as new frost settles the next year. You kneel and scoop a pinch of the dry ice grains. They hiss softly, then vanish into cold vapor. The sensation is like touching snow that never weights your gloves. A soft alarm chimes from your suit. It reminds you to check oxygen levels. The gauge reads steady and full. You breathe slowly and feel calm. We continue our walk across the plain. Ahead sits a glittering shard. It is a meteorite of iron and nickel. Many meteorites pepper this land because Mars lacks thick air to burn them away. The fragment reflects starlight in tiny sparks. You tap it gently. It rings like a miniature bell, bright and clear. Such meteorites reveal the chemistry of ancient asteroids. They also hint at the frequency of cosmic debris storms in this region. We log a sample for future study. The rover arm extends and seals a chip inside a sterile vial. This sample may one day travel to Earth for detailed analysis. A soft breeze moves across the plain. You feel almost weightless in the low gravity. Each footstep lifts dust that hangs suspended before dropping. The sun peeks over the frozen ridge. Sunrise here lasts longer than on Earth. The weak atmosphere diffuses light slowly. Warm colors shift from violet to pink to pale gold. The landscape glows as if lit from within. You sip another warm drink. The steam rises in lazy spirals. It sparkles in the morning rays. In the distance towers, a solitary weather mast. Instruments, they measure ultraviolet radiation. Mars receives more harmful rays because it lacks ozone. Future explorers will need domes coated with radiation shielding. Transparent aluminum is one proposed material. It could let sunlight through while blocking harmful wavelengths. We pause near a shallow trench. The trench exposes permafrost only a few centimeters below. A small sensor touches the ice and records its purity. Water ice here is almost as clean as polar snow on Earth. Another reminder that resources for life are locked beneath the dust. You imagine greenhouses dotting this plain one day. Crops sway under artificial breeze while domes glint like pearls. Children skate on frozen ponds during long twilight hours. The vision fades as you blink slowly. Your eyelids grow heavy like sandbags of gentle sleep. Beyond the trench, the land rises into gentle hills. Wind has carved these hills into streamlined ridges that point south. Their surfaces feel like sandpaper when brushed by a glove. Yardang's record wind direction over thousands of years. We climb one slow step at a time. The horizon reveals a faint spiral plume. That plume rises from a fresh impact site. New craters form every year on Mars. High-speed cameras aboard orbiters catch dark blast zones, spreading in a day. These events expose clean ice that quickly... We descend the Yardang and follow a narrow channel. The channel was once a watercourse during ancient floods. Some floods carried volumes greater than the Amazon River. They raced across plains as short, violent torrents. The scoured bed still shows ripple marks as tall as a house. You place a hand on one ridge and feel its chilled surface. Solar power is scarce at this hour, yet our suit heaters keep steady warmth. Above, a thin cloud appears. This cloud consists of water ice crystals, not dust. Such clouds form in late spring when temperatures briefly climb. They drift slowly and glow pale blue. The rover camera captures the cloud for later study. Scientists will compare its shape to cirrus formations on Earth. We head back toward our camp. The path is marked by reflective stakes. Each stake holds a small light that flashes once per minute. Batteries last long in cold, thin air. Phobos rises again low in the east. Tonight, the moon will eclipse the sun twice. Phobos eclipses last only 30 seconds. Solar panels dim for that brief pause. Sensors record the rapid drop in light. In the camp habiter, the airlock whooshes open. You remove your helmet and breathe recycled air, scented with mint. The campfire hologram starts automatically. It projects realistic flames and gentle crackles. Small speakers add an occasional pop of resin. The sound relaxes muscles in your shoulders. A projection of shooting stars arcs across the dome ceiling. You place samples on a table. Robotic arms sort them into labeled racks. Each rack will travel on a return capsule in 2 years. The capsule will rendezvous with an orbiter, then booster stages will send it toward Earth. You sit on a cushioned bench near the holographic fire. The bench tilts to relieve pressure on the lower spine. You sip herb tea grown in the greenhouse. The tea tastes slightly earthy with a hint of basil. Your heartbeat slows to a calm, steady rhythm. Soft music begins. The melody mimics wind chimes and low cello notes. It is tuned to 60 beats per minute. This tempo encourages alpha brainwave. Alpha waves ease transition into sleep. Lights dim to 10%. The room temperature drops 2 degrees to signal night. Outside, dust devils dance under starlight like silent lanterns. Inside, your eyelids lower as gravity feels softer than before. Mars keeps watch while you drift into a tranquil dream. Our dream tonight begins not far from where we sleep. It starts beneath the pale red sky, inside a dream version of our Martian shelter. But this version hums with soft blue lights and gentle, glowing panels. The walls breathe slowly, like the chest of a slumbering animal. A doorway opens into a hallway that curves upward in a spiral. We walk barefoot down the hallway, each step padded and silent. The floor feels warm beneath our toes, like sunlit rock. Along the walls, constellations bloom and fade in slow patterns. Each star pulses to a gentle rhythm like a heartbeat. You recognize Orion. It's familiar, belt gleaming, steady, yet in this dream, Orion shifts and turns. The hunter transforms into a drifting jellyfish of stars. His bow becomes a wave of plasma curling gently in space. And as we watch, the stars begin to speak. They whisper stories carried on light that traveled for centuries. You lean close and listen. They speak of Barnard's star, only 6 light-years away. It is a red dwarf, small and old, burning slowly. Its planets may hold icy oceans under dark skies. No sunlight reaches them, but volcanic vents may feed warmth. One star tells of Kepler-6, 2F, a planet in the Goldilocks zone. This planet could hold oceans, clouds, and even continents, yet its sun is dim, casting a peach-colored twilight all day. The clouds there never race across the sky. They drift in slow motion, like feathers falling through syrup. Another voice from the stars shares a secret of Trappist. This system has 7 Earth-sized worlds, tightly packed together. On Trappist-1e, you could stand and see multiple planets in the sky. They would appear larger than the moon does from Earth. Daylight comes in a burnt orange hue, dim but warm. The spiral hallway ends in a circular room. Here a planet floats mid-air, slowly rotating. It is Mars, but in its ancient form. Blue oceans shimmer in its basins. lush valleys wind through once dry terrain. You place your hand into the projection. It feels cool and soft, like mist. Memories of this Mars drift into your thoughts. Massive volcanoes like Olympus Mons rise through thick clouds. Its summit is nearly 3 times taller than Mount Everest. You glide upward through Martian air. Winds swirl gently, carrying traces of salt and dust. Below, rivers snake across red land now turned green. Primitive plants cluster near the equator, soaking up thin sunlight. Their roots dig into iron-rich soil, staining it purple as you float higher. Phobos and Deimos orbit close by. They chase each other like siblings in a quiet dance. Phobos completes a full circle around Mars in only 7 hours. This moon rises and sets twice each Martian day. In this dream, it hums like a tuning fork. You float beside Phobos and rest your hand on its surface. The regolith feels like ash fine, dry and silky. Craters dot its skin like freckles. One crater, named Stickney, spans nearly half the moon's width. Through the crater rim, Mars glows in the distance. You breathe deeply, not with lungs, but with the rhythm of stars. Light swirls around you as the dream slowly fades. The floating Mars dissolves into threads of golden vapor. Each thread carries one fact from the journey. Each fact becomes a lullaby within your thoughts. You begin to descend gently back toward your Martian shelter. The spiral hallway reappears beneath your feet. Constellations dim as you pass, offering goodnight glimmers. One last twinkle from Andromeda catches your eye. This galaxy is on a slow collision course with our own. It will not arrive for 4 billion years. By then, the sun will be brighter and larger. Earth's oceans may boil away under its growing heat. But tonight, the stars remain patient and kind. They ask nothing of you but rest. The shelter door opens with a soft sigh. Inside, the lights have dimmed to a dusky amber. Your cot waits, shaped like a cradle carved from stone. A pillow made of soft memory foam molds to your shape. You lie down and feel the warmth of ancient Martian sunlight. The ceiling becomes transparent once more. Above, the Martian sky is velvet black, dotted with steady stars. The Milky Way stretches in a diagonal arc overhead. It resembles a river of crushed diamonds in the night. Shooting stars flicker faintly every few minutes. You spot one fall toward the eastern horizon. It leaves a glowing trail, like chalk on a dark canvas. These meteors may come from ancient comets. Many of them are smaller than a grain of sand, yet they shine brightly as they burn in the thin air. The ceiling glides wider, showing the moons once more. Phobos appears like a fast-moving pebble. Its orbit is decaying. One day it will crash into Mars, but not for millions of years. For now, it orbits like a ticking clock in reverse. You imagine what it would feel like to sleep beneath a collapsing moon. There would be no warning, no sudden sound, just a distant tug from the sky. But tonight, there is only stillness. Even the dust seems to pause and listen. Outside, faint breezes tug at the sand. Martian winds can reach speeds of 60 miles per hour, yet they feel light because the air is so thin. It is more whisper than wind. Grains of sand dance in small spirals, never in storms. You watch the horizon and think of Earth. Your home spins quietly beneath another sky. Earth's atmosphere is thick and full of life. On Mars, the sky is peach-colored by day, violet at dusk, but at night, both planets share the same stars. You remember that stars twinkle only through atmosphere. On Mars, the stars do not twinkle. They shine steady, like fixed beacons in a sea of black. This clarity makes them feel closer somehow. Their light is ancient, but fresh tonight. You begin to imagine Mars as it once was. Billions of years ago, water flowed across its crust. Rivers carved canyons deeper than any on Earth. The largest canyon, Valles Marineris, stretches over 2,500 miles. That is as wide as the entire United States. Scientists believe subsurface lakes may still exist today. They might be warmed by geothermal heat beneath the surface. These hidden seas could harbor microbial life. They lie beneath the South Polar ice cap. Thick layers of frozen carbon dioxide seal them in. If you touched that ice, it would hiss and crack. It sublimates directly into gas, skipping liquid form. The Martian poles change with the seasons. They expand and shrink as the carbon dioxide freezes and thaws. Each year, it is as though the planet breathes. Your breath slows with the planet's rhythm. You imagine red dust settling in ancient footprints, perhaps left by future explorers or by dreamers like you, walking in sleep. This dream is a quiet rehearsal for tomorrow's reality. Above, a soft aurora begins to shimmer near the pole. Mars does not have a strong magnetic field like Earth, but in rare bursts, solar winds still paint the sky. Green ribbons ripple along the thin atmosphere. They look like ghostly curtains flowing in slow motion. You wonder what it would sound like. In this dream, you hear soft chimes echoing. They ring like wind passing through crystal trees. This is the lullaby of a frozen world, a world waiting to be remembered. You pull the blanket higher around your shoulders. Its fabric hums with a subtle thermal pulse. Each pulse mimics a heartbeat, soothing and slow. You are now part of Mars's dust, its stillness, its dream, and the stars above continue their quiet drift. A soft vibration hums through the shelter's foundation. Far below, ancient tectonic plates shift by millimeters. Mars once had volcanoes the size of countries. The largest Olympus Mons stands 13.6 miles high. It is nearly 3 times taller than Mount Everest. Its base is so wide it would cover the entire state of New Mexico. It last erupted around 25 million years ago. No one knows if it is truly extinct. Some believe there is still heat far below, heat that whispers upward, pulsing through Martian stone. You imagine resting at its summit. There, the horizon would curve beneath you. The sky would be dark, even in daylight. Thin atmosphere, unable to scatter much light. Sunlight would look more like a spotlight than a wash. Stars would remain visible, like tiny pinholes through the sky. At that altitude, your voice would vanish quickly. There would be no echo-only silence. Even footsteps would sound swallowed. It is the quietest place you could ever climb. You breathe deeply. The silence here matches the silence of sleep. Still, your thoughts drift like low clouds. They follow the path of Martian dust devils. These are small tornadoes of air and dust. On Earth, dust devils swirl playfully across deserts. On Mars, they can reach thousands of feet high. They leave twisting trails across the surface. The Mars rovers have captured images of them in motion. One even cleaned the solar panels of Spirit rover. Imagine being dusted off by a passing breeze, like nature offering a gentle hand to a weary. Your bed beneath you vibrates with faint warmth. Its support feels almost as if floating. You are drifting now, half asleep in a cocoon of peace. Outside the dome, robotic drones march slowly. They scan soil for traces of perchalots and past water. Their joints hiss and click like sleepy insects. They collect samples and hum lullabies of science. Each step records a page in the Martian diary. You picture yourself walking alongside them, wearing a suit with flexible joints and padded soles. Your boots press into the rusty sand. It puffs up and settles like powdered cinnamon. The entire surface seems to sigh under your step. You pause to look around. Mountains rise in the far distance, blunted by ancient erosion. Their tops glow silver under starlight. Between them, shadowy craters bloom. Some are billions of years old wounds from the solar system's birth. One crater, called Jezero, was once a lake. A delta of clay still marks where water flowed in. NASA's Perseverance rover landed there in 2021. Its goal: to find signs of ancient microbial life. A fossil, a ripple, a whisper of what once was. You close your eyes and imagine Martian fish. Not real, of course, but strange dreams shaped like silver ribbons. They float through ancient riverbeds. They hum to one another with magnetic pulses. Their scales glow like starlight beneath water. You smile in your sleep. Even your dreams are filled with dreams. The shelter's light dims another notch. Now, only the aurora remains visible through the glass. It sways gently like seaweed in a midnight tide. A voice whispers from the control console. It reads you poetry written by astronauts, lines penned while orbiting far above Earth. One says, "I am weightless, yet full of thought." Another, "Silence in space is louder than song." You carry those thoughts with you into rest. They settle in the folds of your dreams. Tonight, you are more than a visitor. You are part of Mars, woven into its night, its heartbeat, its hush, its hum forever. The air inside the dome is thin but warm. Your breath forms tiny clouds in the cooler corners. Outside, stars twinkle, cold and distant. You gaze up, tracing the path of Mars to moons. Phobos and Deimos, small and fast, dance in silent orbit. Phobos orbits so close, it rises and falls twice each Martian day. Its surface is covered with craters and grooves. One crater, Stickney, is so large it nearly splits the moon in two. Scientists think Phobos might be a captured asteroid. Deimos is smoother, rounder, and slower. You imagine standing beneath Phobos as it passes overhead. Its shadow streaks across the red plains. It races faster than Mars spins beneath it. This means Phobos rises in the west and sets in the east. A surprising twist for anyone who has only watched Earth's moon. You stretch and settle back into the sleeping pod. Your thoughts float to gravity 1/3 that of Earth's. Walking here would feel light, almost like a slow dance. Jumps would be higher, steps softer, each movement a gentle glide through the low air. It is easy to feel weightless, as if floating in a dream. Your mind wanders to the famous astronomer Percival Lowell. In the early 1900s, he imagined canals crisscrossing Mars. He thought intelligent beings built them to carry water, though we now know the canals were optical illusions. His ideas sparked generations of curiosity and science fiction. From those dreams, Mars became a symbol of mystery and hope. Your heart slows to match that quiet wonder. You feel the dust settle, both outside and inside. Sleep draws nearer with every passing breath. The shelter's lights flicker, mimicking a Martian sunset. It lasts twice as long as an Earth sunset, almost 2 hours. Colors shift softly from orange to deep violet. A delicate dance of light and shadow on red rocks. You picture yourself outside, watching the sun slip beneath horizons. Nearby, a faint glow pulses in the Martian night. It is an aurora, like Earth's northern lights. Charged particles from the sun meet Mars' thin atmosphere. They create ghostly curtains of green and red. Though smaller and weaker than Earth's, they are no less magical. You listen to the quiet hum of scientific instruments. They monitor weather, radiation, and dust storms. Sometimes winds sweep across the plains with fierce strength. Martian dust storms can last for months, hiding the surface. You imagine the dome protecting you like a warm shell. Outside, the temperature drops below -100 degrees Fahrenheit. Inside, warmth wraps around you like a soft blanket. Your eyelids grow heavier. The silence deepens. You drift into a calm, knowing sleep. Mars watches over you, a silent guardian of the night. You breathe deeply, feeling the calm that Mars inspires. Your mind drifts toward the ancient riverbeds carved long ago. Once, water flowed freely across this planet's surface. Now, it hides mostly as ice beneath the rusty soil. Scientists discovered vast glaciers under layers of dust. The thought of hidden water sparks dreams of life. Could tiny microbes still survive in underground caves? Perhaps in these dark refuges, life clings quietly. This hope fuels missions to search beneath the surface. Every rover and satellite carries this silent question. Above, the stars shine brighter through the thin atmosphere. Without thick clouds, the cosmos seems close and clear. The Milky Way stretches across the sky, a glittering river, each star a sun, many with their own planets. Some may even harbor worlds like Mars or Earth. You imagine drifting along that glittering river, floating past sparkling star clusters like the Pleiades. These 7 sisters are a favorite for stargazers. Their light takes about 444 years to reach us, a gentle reminder of time's vastness and patience. As you drift further, nebulae bloom like cosmic gardens. The Orion Nebula glows pink and purple, a stellar nursery. Here, new stars are born from clouds of gas and dust. The delicate balance of gravity and pressure weaves life, a cosmic cradle rocking the next generation of suns. You'll feel a soft pull as your journey slows near a glowing cloud. This is the Helix Nebula, sometimes called the Eye of God, a beautiful death of a star, shedding its outer layers. Colors swirl gently in patterns, both chaotic and serene. It is the universe's reminder that endings birth beginnings. You pause and breathe deeply, imagining this vast ballet. Softly, your body follows the rhythm of distant pulses. The spinning neutron stars send beams of light like lighthouses. Each pulse is steady, a cosmic heartbeat in the dark. You fall into the soothing cadence of the cosmos. Resting under a sky full of wonders, your thoughts return to Mars. Studying the planet's secrets, you picture the rover Perseverance, exploring rocky plains. Its laser zaps, tiny samples, every discovery, a small step for humankind's dreams, stretching nearly 12 hours. The future here feels quiet, but full of promise. The Martian night is long. Cool winds carry whispers from ancient valleys. You drift deeper into restful sleep. You imagine the red dust settling softly on your skin. Guardians of your dreams. Calm and still, the stars outside shine gently. Far beneath the Martian crust, scientists believe ancient aquifers may still exist. These underground lakes could hold clues to microbial life. Mars has clay minerals that only form in water. This suggests long periods of warmth and wetness in its past. You picture those ancient lakes shimmering under a younger sun. The Martian year is almost twice as long as Earth's. One orbit around the Sun takes 687 Earth days. This long year gives the seasons time to stretch and sigh. Its tilted axis brings chilly springs and dry, windy autumns. You can almost feel the crisp Martian breeze in your thoughts. The tallest volcano in the solar system rests here, Olympus Mons. It stands nearly 3 times the height of Mount Everest. Its gentle slopes stretch so wide you cannot see its edge. If you stood on its summit, the curvature of Mars would disappear. You imagine yourself floating above it, weightless and peaceful. Nearby, the Valles Marineris yawns across the surface. This canyon system dwarfs the Grand Canyon in length and depth. It stretches over 2,500 miles across the Martian surface. It may have formed from tectonic cracks and collapse. You imagine drifting through this canyon like a slow-moving cloud. The ground below is silent, broken only by dust devils. These swirling towers of wind dance across the desert quietly. They can grow taller than skyscrapers, but carry little force. Their shadows spiral across the rust-red terrain in silence. The wind's whisper is more lullaby than alarm. In the distance, a meteor crater glows under starlight. This is the Jezero Crater, where curiosity once explored. You see its dusty tread marks frozen in Martian soil. It studied methane levels, clay deposits, and ancient. Its journey gave us clues to water's ancient song. Mars has two moons, Phobos and Deimos. Phobos orbits so closely it rises and sets twice a day. Its surface is scarred, like a sponge worn with age. Deimos is smaller, drifting quietly at a slower pace. They are thought to be captured asteroids from long ago. Their irregular shapes remind us how gravity can be gentle. Even a moon held tightly can still dance across the sky. You imagine riding Phobos in slow orbit above Mars. The world turns below, quiet and still. A red sea of dunes and craters under velvet black skies. Your body grows still as you drift past imaginary cities. Domes shimmer beneath the Martian twilight, protecting fragile human life. Inside, glowing greenhouses nurture earth plants in alien soil. Astronauts sleep in small rooms, breathing filtered air. Even far from home, the need for rest remains sacred. And in your sleep, you join them floating, dreaming, and learning. The stars remain unchanged, blinking softly through glass domes. You are safe here, resting among discoveries and dust. The hum of machines is soft and constant, like breathing. Outside, the stars continue their silent story in slow rotation. The Martian twilight dims slowly, leaving a golden hue across the horizon. The thin atmosphere scatters sunlight into a soft orange glow. It is quieter now, as if the entire planet exhales. You watch as the last light kisses the rim of a crater. The stars begin their steady shimmer across the evening sky. With no city lights to block them, every star shines brighter here. Mars offers one of the clearest night skies in the solar system. Even the faintest constellations can be seen with the naked eye. You spot Orion, stretching his arms across the void. Nearby, the Milky Way drapes itself like a glittering blanket. Time slows on this cold, peaceful planet. Each second seems stretched like a yawn. Even gravity is lighter, letting your limbs feel loose and airy. You imagine drifting gently above the surface, as if in a dream. You are not falling, you are floating through knowledge and silence. The Martian poles hold frozen secrets in their icy caps. Carbon dioxide snow falls there in winter, like powdered silver. These caps grow and shrink with the seasons, breathing in time with the planet. Beneath them, water ice waits in silent sheets. This frozen water may someday water gardens on a distant colony. Even now, plans for human exploration quietly unfold. Robots map landing zones, measure radiation, and test soil samples. NASA and other agencies dream of homes on Mars. But tonight, your home is a dream, shaped like a star. No oxygen tanks required. Only your breath slowing gently with rest. The stars rotate slowly above your imaginary dome. A small campfire flickers beside your cot, keeping the shadows warm. The fire crackles, but only softly, as if it too is sleepy. Shooting stars skim the sky like glowing feathers. Some are meteoroids brushing past Mars' atmosphere and burning into memory. Beyond Mars, you sense the presence of other planets. Jupiter looms far off like a glowing marble of storm. Saturn spins with grace, its rings shimmering in reflected sunlight. But Mars feels more like home tonight, wild, rusted and full of wonder. You'll picture its surface dotted with future lights and laughter, and maybe, just maybe, one day your descendants will sleep here. They will look up at Earth as you look at Mars now. It will be a bright blue star to them, glowing with memory. They will tell bedtime stories about oceans and forests. Just as you now dream of dust storms and red skies, your breath grows slower, your mind floating between thoughts. The journey ends not with a goodbye, but with a soft settling. Mars, in all its silence, becomes the coziest place to fall asleep. Even time itself seems to nap here, curled around ancient stones. And you, quiet traveler, are safely tucked beneath the stars. And now, dear, let us leave the winds of Mars behind. Let us fold the map of this red world and place it gently beneath your pillow. You have wandered its rusty plains, floated through its soft gravity dreams, and watched stars shimmer with ancient memory. The dust has settled, the air is still, and so are you. The campfire beside you glows a little softer now, its light flickering in warm golden tones against the inside of your eyelids. Its gentle crackle hums like an old lullaby, one that has drifted across galaxies. Each one a final thought for the day, a small goodbye from the universe, telling you it is time to rest. No more words to listen for, only the calm, the hush, the warmth. Let your body go heavy, let your thoughts go light. You are safe here, in the orbit of dreams, surrounded by stars, cradled by the cosmos. Breathe in the glow, breathe out the dust, and let the quiet carry you far beyond Mars, beyond the fire, beyond thought, into the deepest, most beautiful sleep you have ever known. Good night, my quiet explorer. Sleep well beneath the stars. The universe will keep watch while you dream.